Hello everyone. It is my great honor to present our research on the millimeter wave beam scanning phased array with switchable broadside and Endfire radiation pattern using phase-controlled elements. Millimeter wave-related research has begun to receive a lot of attention. Now, due to the characteristics of millimeter waves, new requirements for millimeter wave antennas have emerged, particularly the wide-angle scanning capabilities to enhance communication quality. Inspired by phase-controlled antennas, we propose a novel millimeter wave phased array with a switchable radiation pattern. The proposed antenna features two dielectric layers, a linearly tapered radiating slot, an N-shaped feeding line with dual ports, and a pair of stacked patches. When both ports are excited in common mode, the current primarily concentrates on the symmetrical rectangular patches on sub-1 and sub-2, forming an equivalent magnetic wall along the middle line, creating a current zero point. The current flows in the same direction along the slot edges on both sides, and the slot cannot radiate. In differential mode, the radiation from the current distributed across these two patches cancels out. The current flows along the N-shaped feeding microstrip line from one port to the other, forming an equivalent electric wall along the middle line. Part of the current is coupled to the ground plane, with current flowing along the edges of the linearly tapered slot. In common mode, the electric field primarily concentrates on the stacked patch of the proposed antenna, similar to the TMO1 mode operation. This configuration results in a broadside radiation pattern. When operating in differential mode, the tapered open-ended slot becomes the radiator, and radiates outward from the slot edge, indicating that the proposed antenna element has an Endfire radiation pattern. The array comprises 4 beam steerable antenna elements arranged linearly in a row. We obtained the beam scanning radiation pattern of the prototyped array using the active element pattern method, and beam synthesis is performed using MATLAB software. The calculated active S parameters of the proposed millimeter wave phased array are less than -10 dB within the operating bandwidth of 24 to 28 GHz. The proposed array exhibits a peak gain of approximately 10.5 dB in common mode and 8.5 dB in differential mode. In the broadside direction, the proposed phased array exhibits a 3 dB beam scanning range of ±55 degrees, with a side lobe level below -5 dB. In differential mode, the array achieves a scanning range of ±65 degrees with a 1.5 dB gain fluctuation, and side lobe level below -5 dB. Compared to related work, our proposed array has better performance. Thank you for your listening.